Yes, the last topic of this chemical equilibrium is Le-Chatelier's principle. This Le-Chatelier's principle is used to find the amount of the major product whenever the equilibrium is imbalanced by the addition of the external pressure, external temperature, or by the addition of any one of the reagent in excess quantity, or whenever inert gases like helium, neon, argon, krypton, when these elements are added, then in particular it is based upon how the equilibrium chemical reactions are affected by means of external constraints. That is discussed in the Le-Chatelier's principle. Now, according to Le-Chatelier's principle, whenever external constraint means here external pressure, external temperature, or addition of the any one of the chemical, or addition of the inert elements, these are called as an external constraint. When these constraints are added to the equilibrium system, then equilibrium is shifted in such a way that it counteract or it nullify the effect of the applied constraints or applied pressure or applied temperature or external addition of the any one of the chemical or the addition of the new, that is a zero group elements or inert gas elements. Therefore, very important. Now, what do you mean by Le-Chatelier's principle? What is meant by Le-Chatelier's principle? According to Le-Chatelier's principle, if a system is in equilibrium, is subjected to a constraint. According to Le-Chatelier's principle, according to Le-Chatelier's principle, according to Le-Chatelier's principle, if a system in equilibrium is, if a system in equilibrium is, if a system in equilibrium, in a system in equilibrium, system in equilibrium is subjected to a constraints, is subjected to a constraint such as pressure, such as change in temperature, such as change in temperature, pressure or concentration. Pressure or concentration, then the equilibrium is shifted. In the equilibrium is shifted. Equilibrium is shifted in such a way. Equilibrium is shifted as to nullify the effect of the constraint. Effect of constraint. According to Le-Chatelier's principle, if a system is in equilibrium, is subjected to a constraint. This is very important. Constraint such as change in temperature, change in temperature or pressure or concentration, then its equilibrium is shifted in such a way as to nullify the effect of the constraint. Means it would counteract with that of the effect of the constraint, like change in temperature, change in pressure, or change in the concentration of the any one of the reactant. Therefore, either it moves to the forward direction or it moves to the backward direction. In some cases it moves to the forward direction, in some cases it moves to the backward direction. This is called as a Lee-Chatelain's principle. This is very important one for your board exam preparation. They will ask in 1 marks or 2 marks question, state and explain Lee-Chatelain's principle. State and explain Lee-Chatelain's principle. Okay, you have to follow this one. Now, application of the Lee-Chatelain's principle. Application of the Lee-Chatelain's principle to the synthesis of ammonia. Application of Lee-Chatelain's principle. Application of Lee-Chatelain's principle to the synthesis of ammonia. Application of Lee-Chatelain's principle to the synthesis of ammonia. This is also very important question. In 3 marks they will ask in our board exam preparation. Application of Lee-Chatelain's principle to the synthesis of ammonia. Ammonia is synthesized by Haber's process. Nitrogen in gaseous phase and hydrogen in gaseous phase. Then it gives rise to ammonia. It gives rise to ammonia that is in gaseous phase. Then it attains the equilibrium. Equilibrium is half arrow mark. Equilibrium. Then delta H is equal to minus 92.4 kilojoules. Delta H is equal to minus 92.4 kilojoules. Delta H is equal to minus 92.4 kilojoules. It is a homogeneous chemical reaction. It is a reversible chemical reaction, and it is an exothermic chemical reaction. It is a homogeneous reversible chemical reaction. It is a homogeneous reversible chemical reaction. Now, why it is called homogeneous chemical reaction? Because the reactants like nitrogen and hydrogen and ammonia, that is all are in gaseous state, and hence it is called homogeneous one. What is reversible? Here the arrow mark in either ends, and hence the reaction is a reversible reaction. This is also, and it is a homogeneous reversible chemical reaction and exothermic reaction. Exothermic reaction. Exothermic reaction means a chemical reaction is associated with the liberation of the heat energy. Delta H of the process would be negative, then the reaction is considered as a exothermic reaction. Then here we have the term, what do you mean by exothermic reaction? A reaction accompanied by the liberation of heat energy. A reaction accompanied by the liberation of heat energy. A reaction accompanied by the liberation of heat energy. Heat energy is called exothermic reaction. A reaction accompanied by the liberation of heat energy is called exothermic reaction. For exothermic reaction, delta H is negative. Delta H is equal to negative. For exothermic reaction, delta H is equal to negative. Delta H is equal to negative. Okay, it is a homogeneous reversible chemical reaction and exothermic chemical reaction. What is the effect of temperature? What is the effect of temperature or effect of pressure? Effect of pressure on equilibrium. Effect of pressure at equilibrium condition. Now, how do you explain the effect of pressure on equilibrium condition? When you feel to apply the effect of pressure on the reversible chemical reaction, homogeneous chemical reaction, it is to be noted that the reactant side how many moles and product side how many moles. In the reactant side 1 plus 3 is equal to 4 mole, and in the product side that is only 2 moles. Here the number of moles of the reactants are greater than the number of moles of the products. That is one option. In some chemical equations, if it is the number of moles of the reactants is equal to the number of the moles of the products. For example, decomposition of hydrogen iodide, or number of moles of reactants are 2 and number of moles of the products are 2. Therefore, in such cases, both sides are equal. In some cases, the number of products are more than the number of moles of the reactants. Number of moles of the products are greater than number of moles of. Three conditions are there. Three cases will be there. In some cases, number of moles of the reactants are greater than the number of moles of the product. In some cases, number of moles of reactants is equal to number of moles of the products. In some cases, number of reactants are less compared to the number of moles of the products. Now, three conditions. Number of moles of products, number of moles of products greater than number of moles of reactants. Number of moles of reactants. Number of moles of reactants. Number of moles of products are greater than number of moles of. Just it is imagine that this is your question paper maximum marks. This is nothing but your marks secured. Means the efficiency is small. Assume that is a 4 marks, you secured only 2. 1 plus 3 is equal to 4. 1 plus 3 is equal to 4. That is equal to 4 moles of the reactants. That used up to give 2 moles of the products. 2 moles of the products. 2 moles of the products. Just imagine, in your question paper you have the 4 marks, but you scored only 2 marks. What your teacher will do? Teacher will apply pressure. What your parents do? Your parents will apply pressure. Whenever LHS is more, RHS is less. When you are in marks sheet, if suppose 50 out of 100, what is this 50? Your marks scored. This is 100 maximum marks. Whenever the numerator is less than the denominator, always it is indicates that your teacher will applying pressure or your parent will applying pressure. If suppose he scored 100 out of 100, 100 out of 100, then your teacher is thinking, oh, you are not supposed to apply pressure because he is perfect. Therefore, whenever the number of moles of the reactants and products are equal, then we are not supposed to apply pressure. If you apply pressure, pressure has no effect. If you apply pressure, pressure has no. Suppose the chemistry 70 mark is maximum marks, that I scored 70. Then what about the application of the pressure? Whether the teacher end we are imposing any pressure, whether the parent end then imposing any pressure, no pressure, because pressure has no effect. If the marks secured is equal to the maximum marks, LHS and RHS both are equal. On the other hand, if suppose this is nothing but 50%, 50% is nothing but 50 by 100. That is the 4 moles of the reactants and 2 moles of the products. This is nothing but 50%. That is 50 marks is secured and 100 marks in question paper. Therefore, if suppose that is the case, if your efficiency is less than 100 or that is equal to 50%, then to score good marks, the pressure is always required. That is why your teacher is calling and he is advising, or your parents is calling and is advising, you have to score the good marks in next test. Therefore, that is nothing but what you are thinking, oh, that is external pressure. Therefore, whenever the number of marks secured that is less than the maximum marks in question paper, always pressure is required. If suppose the marks secured is equal to maximum marks, then either the application of the pressure has no effect. In some cases, if suppose the 70 marks question paper is there, he answered all 105 marks and all the 105 marks is perfect. If suppose the 70 mark is the question paper, 70 mark is the question paper, if suppose they are asking and you write all the 105 marks, maximum marks question paper, then what the teacher is doing, he is advising, you are not supposed to answer all the 105 marks questions. Some teachers still advising, you are not supposed to write all this. Means they are promoting to decrease the pressure. They are promoting to decrease the pressure. You are not supposed to take any tension. 70 sufficient. Therefore, be perfect with that of the 70 mark questions. That's why they are reducing the pressure. What about the tension in the student's end? What about the stress in the student? It is removed by means of the teacher. If suppose he answered all 105 marks questions out of 70 marks question in chemistry question paper. Is it clear? Three category of the students are there. Some of the students they are scoring less mark compared to the maximum mark. Some students they are scoring equal marks. What about the maximum marks in the question paper? The same marks. Some students they are writing all 105 and all 105 is perfect. Rare students they are doing like this. 105 marks they secured out of this 70. Our requirement is 70. But what the students are doing, some students, they are very perfect in chemistry. They write all the questions and all the questions are perfect and they secured 105 marks. 105, but the teacher is selecting the few very important one and they will give the marks report, that is progress report, 70 out of 70. Okay. Now, if suppose the number of moles of the products are greater than the number of moles of the reactants, then in order to increase the amount or yield, high pressure is required. That high pressure is required. High pressure is required. High pressure is required. High pressure is required. But therefore, what is the effect of the pressure? What is the effect of the pressure? Whenever the number of moles of the products are greater than the number of moles of the reactants, then the yield is very less. Therefore, yield is very less means you know how the products molecules are formed. Product molecules are formed whenever the reactant molecules that undergoes collision. Just observe the mechanism of the chemical reaction. Suppose you are keeping 1 mole of the nitrogen and 3 moles of the hydrogen in a closed cylindrical container, because I mentioned if the chemical reaction is said to occur in that is a reversible direction, then what is the condition? Both reactant and product molecules that should be kept in the same vessel, and the product molecules that are not allowed to escape from the container, and one more is what about the conditions that maintains constant throughout the cylindrical container. This is condition. Suppose when you are applying pressure, molecules of nitrogen and hydrogen will come close together and they will hit with one another. They collide with one another. When the nitrogen and hydrogen molecules come close together and collide with one another, then some of the molecules which are considered the active molecules, they are ready to give the products. That is the mechanism behind it. Means by the application of the pressure only, the molecules of nitrogen and hydrogen will come close together and they undergo collision. Then some of the collisions are very effective. Those type of collisions are called effective collisions and they are properly oriented. These effective collide molecules are properly oriented. Then they are ready to give the products. That is why increase in pressure increases the yield of the ammonia, because the number of moles of products are less, number of moles of reactants are more. In such cases, increase in pressure increases the amount of the product or yield of the product. But decrease in pressure, what is the effect of decrease in pressure? Whenever the pressure of the system that decreases, this is only required for the backward direction. Here 2 moles of the reactants react to give the 4 moles of the product. 2 moles of the reactant react to give the 4 moles of the product. That is third case. The question paper has 2 marks and the mark secured is equal to 100. In a 50 mark the question paper, the options are always there that gives the 100. The student answers all the 100 marks questions, but the requirement is only 50. In such cases, decreases the effect of the applied constraint. The pressure decrease will occur. Therefore, what about the increase in pressure that favors for the forward direction, decrease in pressure that is favor for the backward direction. When pressure is applied to certain limiting extra value, then ammonia decomposes. That is why appropriate pressure, that is called as a moderate pressure, is required in order to get the maximum yield. Increase in pressure, of course, the required for the forward direction, but beyond certain limiting value, ammonia decomposes to give back that of the nitrogen and hydrogen. But weak pressure or lesser pressure, the yield will not be formed. Lesser pressure means you are keeping the piston above the molecules. Therefore, whenever the piston is above or below that pressure, what is the required for that of the formation of the ammonia, what happens actually, the nitrogen and hydrogen molecules when come close together and they hit with one another or collide with one another, then only the yield will be formed, ammonia is formed. Whenever the pressure is less, then what happens, nitrogen and hydrogen, they won't come in contact with each other. Therefore, there is no possibility of the collision and effective collision. There is no properly orientation of the molecules, and hence the yield will be very less. Therefore, low pressure decreases the yield of the ammonia, high pressure increases the yield of the ammonia. Therefore, high pressure is required for the forward direction, that is for the synthesis of ammonia. Low pressure is required for the backward direction, that is for the decomposition of ammonia into nitrogen and hydrogen. Is it clear? This is about the effect of the pressure on equilibrium condition. Effect of pressure on the equilibrium condition. Now one more is effect of temperature. Effect of temperature. Effect of temperature. According to the above equation, reaction is exothermic. Reaction is exothermic because it is associated with the liberation of heat energy. Delta H for the process is negative for exothermic reaction. How to identify the exothermic reaction? If observe, if next to the delta H, if you got the minus, that it is a exothermic reaction. You know that in one of the very important concept in thermodynamics chapter, that is a Lavoisier's and Laplace law. According to Lavoisier's law, according to Lavoisier's law, according to Lavoisier's law, that is in thermochemistry. According to Lavoisier's law in thermochemistry, if the forward reaction is exothermic, comma, backward reaction is endothermic. Backward reaction is endothermic. Backward reaction is endothermic. Forward reaction is exothermic and backward reaction is endothermic, and vice versa. And vice versa. Okay. Now, according to the above equation, the reaction is exothermic. Therefore, to increase the yield, low temperature is favored. Low temperature is favored. Low temperature is favored. But at too low temperature, what happens? Low temperature is required, of course. But when the too low temperature is applied, you know when does the chemical reactions will occur? Why temperature is required? With increasing temperature, the momentum of the molecules increases and kinetic energy increases and collision rate increases. Whenever T increases, when temperature increases, momentum also increases. Momentum of the molecules increases. Momentum of the molecules increases. Kinetic energy increases. Collision rate increases. Number of effective collisions increases. All collisions will not used in the formation of the product. Only certain number of the collisions are used in the formation of the product. Those type of collisions are called effective collisions. Hence, amount of the product increases. Amount of the product increases. This is the temperature factor. How does it affect the rate of the chemical reaction or velocity of the chemical reaction? Therefore, actually increases the yield. Already the reaction is exothermic. The product always acquires the higher amount of the energy. But even by further increasing the temperature, what happens? The decomposition of the ammonia will occur. Thermal decomposition of the ammonia will occur. Then it gives rise to nitrogen and hydrogen. Therefore, your objective is to reduce the temperature. But how much extent we can reduce the temperature? But still lowering that of the temperature, the collisions will not occur. Therefore, you have to manage the optimum temperature at which the velocity of the reaction is quite high in the forward direction. Is it clear? Therefore, actually the reaction is exothermic in nature. In exothermic, the product obtained are associated with the higher amount of the kinetic energy. Because the higher temperature is maintained, higher amount of the kinetic energy, but still increase the temperature, what happens? The backward reaction proceeds. That is undergoes the decomposition of the ammonia into the nitrogen and hydrogen will occur. But our objective is to reduce the temperature in the forward direction. But by reduction of the temperature in the forward direction, what happens? By reduction of the temperature, the molecules will not undergo collision with one another. That is the reason why optimum temperature is required to bring about the maximum yield in the synthesis of ammonia. Is it clear? Okay. Then effect of pressure is over, effect of temperature is over, and effect of the addition of any one of the reactant. Effect of change in concentration. effect of change in concentration, effect of change in concentration. You know that QC is equal to, yesterday we discussed about the QC is equal to concentration of ammonia whole square divided by concentration of nitrogen into concentration of hydrogen whole cube, concentration of nitrogen and concentration of hydrogen to the whole cube. Is it clear? What about the QC and KC? Mention the differences between QC and KC. What about the difference between KC and QC? KC is equilibrium constant, equilibrium constant, equilibrium constant, means this is only under equilibrium position. Other than this equilibrium position, we are referring that as the QC. Other than this equilibrium position, at any position, this is both are the constant factors. Both are constant factor, equilibrium constant. Therefore, that constant is obtained under equilibrium position. That is called as a QC. That is a KC. Whereas the QC stands for under any state of condition other than this, and other than KC. Now, whenever nitrogen and hydrogen concentration is increased, when nitrogen concentration is increased, QC is given by means of concentration of ammonia whole square divided by concentration of nitrogen into concentration of hydrogen to the power of 3. Now, if suppose the nitrogen concentration is added, what happens? Actually, denominator is increased, then the total value decreases. Total value decreases since QC is constant. Therefore, in order to maintain the QC constant, then we have to increase the concentration of the ammonia. This implies that more and more amount of the nitrogen and hydrogen that would react to give the ammonia such that making QC value as a constant. If suppose hydrogen is added under equilibrium condition, then what happens actually? The denominator value will be increased. In order to maintain denominator value is increased, means total value will decrease, KC will be decreased, sorry, QC will be decreased. Therefore, in order to maintain the QC value constant, that we have to increase the numerator value also. Therefore, increase the numerator value. This implies that ammonia, that product that formed would be higher. This is about the application of the Leach's principle to the synthesis of ammonia by changing the concentration of any one of the reactant or product. Whenever the concentration of nitrogen increases, concentration of nitrogen suppose increases, concentration of nitrogen increases, what happens? Denominator increases, denominator increases, total value decreases, total value that is QC, total value that is total value QC decreases. In order to increase QC, in order to make constant, in order to keep QC constant, NH3 concentration would be increased. NH3 concentration would be increased. Therefore, forward reaction rate increases. Forward reaction rate increases. This implies yield of ammonia increases. Yield of ammonia increases. Is it clear? Similarly, by increasing the concentration of the hydrogen also, the denominator value increases. Therefore, the total value QC decreases. In order to make, since QC is always constant at given temperature, therefore, in order to make the QC constant, more amount of the yield, that is ammonia, is formed, and hence the velocity increases, rate increases in the forward direction. Is it clear? Same concept for when hydrogen concentration increases. hydrogen concentration increases. When hydrogen concentration increases, denominator increases, QC decreases. In order to maintain the QC constant, product will be increases, means the numerator will be increases, make them the ratio is always fixed. That is the ammonia concentration divided by N2 into H2, that is always constant. Is it clear? Is it clear? Okay. Then effect of adding inert gases. Effect of adding inert gases. Effect of adding inert gases. Effect of inert gases. Inert gases means zero group elements. Zero group elements are called inert gases. At constant volume, at constant pressure. No, that is under constant pressure and constant volume. Constant volume, at constant volume, at constant volume and constant pressure. At constant volume and constant pressure. Constant volume. Constant volume means that is a closed vessel. It is a closed vessel. It's called as a constant volume. If an argon is added, if an argon, that is an inert gas, argon is inert gas, is added, if argon is added under equilibrium, argon is added under equilibrium in a closed vessel, in a closed vessel, what happens? Pressure increases because the volume is fixed. Pressure increases. Pressure increases. Pressure increases. Pressure increases. Pressure increases. However, the total number of moles of gas also increases. However, total number of moles of gases also increases. However, the total number of moles of gas also increases. Total number of moles of gas also increases. Total number of moles of gas also increases. As a result, partial pressure of any gas do not change. As a result, partial pressure. As a result, partial pressure of any gas. Partial pressure of any gas does not change. Partial pressure of any gas does not change. Partial pressure of any gas does not change. Does not change. And hence does not change. And hence equilibrium is constant. And hence equilibrium is constant. And hence equilibrium not disturbed. Equilibrium does not disturbed. Equilibrium does not change or does not disturb. See, at constant volume means this is the conditioned. Constant volume is the volume of the cylinder remains constant. Here you are placed always nitrogen and hydrogen. Nitrogen and hydrogen. You are keeping this argon, that is the inert gas, is added. Therefore, what happens? The amount of the molecules increases. Pressure inside the system that also increases. Pressure inside the system increases. However, the number of molecules of the gas will be increased. Number of moles of gas. Suppose 1 mole of nitrogen, 3 moles of hydrogen, and some of the moles of argon, that will be increased. Therefore, as a result, partial pressure of the nitrogen or partial pressure of the hydrogen or partial pressure of the argon, that also partial pressure. Hence, as a result, partial pressure of any gas does not change. Partial pressure of the system remains constant, and hence the equilibrium is not disturbed. If the partial pressure of any one of the system that changes, then only the equilibrium is altered. Since partial pressure of any gas is not changes, therefore the equilibrium is not disturbed. This is the effect of the addition of any one, that is inert gas to the system. Effect of addition of inert gas to the system. Now at constant pressure. At constant pressure means open system. Constant pressure means open system. Pressure means open system. At constant pressure means open system. In open container or open system, open container means open system. In open container or open system, here already we have nitrogen and hydrogen. You are adding this argon or any one of the zero group element in excess. What about in such cases? That is, volume increases. Volume increases. If an inert gas is added at a constant pressure, that is an open vessel, volume of the system increases. If an inert gas, say argon, is added to the system, in open container, added to the system in open container, then what happens? Open container, volume of the system increases. Volume of the system increases. Volume of the system increases. See, at constant pressure, volume of the system increases. At constant volume, pressure of the system increases. See the previous and this example. This is at constant pressure, volume of the system increases. Volume of the system increases. At constant pressure, volume increases. At constant volume, pressure increases. Constant volume, pressure increases. Volume of the system increases. System tries to increase the number of moles of per unit volume. System tries to increase number of moles per unit volume. System tries to increase number of moles per unit volume. System tries to increase. System tries to increase. System tries to increase the number of moles. The number of moles. Number of moles per unit volume. Number of moles per unit volume. Number of moles per unit volume. The system tries to increase the number of moles per unit volume. Whenever at constant pressure the volume increases, therefore the number of moles increases per unit volume by increasing the total number of moles. 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 As the number of moles increases, backward reaction. As the number of moles increases in the backward reaction, equilibrium is shifted to the left side. The number of moles as the number of moles increases in the backward direction. Number of moles increases in the backward direction. Number of moles increases. Number of moles increases in the backward direction. Increases in the backward direction. Number of moles increases in the backward direction. Number of moles increases in the backward direction. Therefore, equilibrium gets shifted to the left side. Therefore, equilibrium shifted to the left side. Therefore, equilibrium shifted to the left side. Equilibrium shifted to the left side. Equilibrium shifted to the left side. Now, at constant pressure, this is an open system, that is in closed system. If an inert gas, say argon, is added to the system in an open container, then what happens? Volume of the system increases. Volume of the system is, initially we have nitrogen, hydrogen and argon. The volume of the system increases. Volume of the system tries to increase the number of moles per unit volume. Therefore, the number of moles of the gaseous system per unit volume also increases. So, initially it was only nitrogen and hydrogen. Now we are adding argon. Therefore, the number of moles per unit volume of the container that will be increased. Therefore, by increasing the total number of moles, as the number of moles increases, the backward reaction, as the number of moles increases in the backward direction, therefore at equilibrium shifted in the backward directions. This implies when you are adding argon, when you are adding any inert gas at constant volume, then the reaction proceeds in forward direction. When you are adding this argon or any inert gas into constant pressure, then the equilibrium is shifted towards the backward direction. Is it clear? This is an open system, that was a closed system. Therefore, now we have the four effects. Increase. What is the effect of temperature? What is the effect of temperature? What is the effect of concentration? What is the effect of the inert gases? Like that of the argon, at constant pressure and constant volume, when they are added, what is the result? That is explained on the basis of Le-Chatelier's principle. Is it clear? From this, I will conclude the chemical equilibrium. Tomorrow, I will start the ionic equilibrium. Thank you.